Guys ready? Can we hang on for another hour, hour and a half? Be awesome. Okay, so we're going to shift gears. This is now less about exploring technologies and more about applying techniques. I'm going to do that in the context of a workshop. And in that workshop, together we're going to create the car site of the future, featuring the car of the future, which I'm going to show you now. Right, where's my Chrome? New window. This is the future Go. Part smart car, part Segway. It's the personal transportation device of the future to help us survive the increasingly harsh conditions of a future world of zombie apocalypses and other nefarious developments. So what we have here is a detailed 3D model, which we're going to talk about how we create in this section and export and implement and bring into this environment. When I use the mouse and roll over parts of the car, that triggers a div appearing in different parts of the screen. When I click on this tab over here, it animates these windows, open and closed. Click this one and get these guys spinning. Not only that, I can rotate this model interactively. I'm just dragging mouse right now, using a trackpad to zoom in and out. And because no self-respecting product visualizer is complete, especially a car configurator, without the ability to change colors, I can drag and change the colors. So this starts becoming more like what we're going to build in the real world with WebGL. One type of application, and actually a pretty common one. So that's why we're going to look at this one, because it illustrates a lot of the design patterns and concepts and applications that we're going to want to build with WebGL. Namely, centerpiece, money shot of a 3D model at its heart. A product, a physical product, a bicycle, a machine, a car, some object that you want to share with your marketing team because you're about ready to start product marketing it. Maybe you're in the design team. I mean, some furniture you want to sell on an e-tailing site, right? Very common. At the center is the model, a way to manipulate the model interactively, a way to click on parts to interact with it, and 2D user interface surrounding the whole thing, showing off brilliantly the compositing abilities of your web browser, right? Look at this over here. Guess what? That's a div with some alpha on it, right? Z-indexed in front of this. Well, guess what? See that beautiful gradient in the background here? See that purplish stuff? That's just background image on the body of the page. But because we got that wonderful transparency we talked about, we see that background image through the grid and the car model. And these tabs, just more divs, right? This rollover, just a div. So let's get into it. How do we do it? What do we have to think about in order to do this? Well, we've already seen that there's a lot of technologies in play here, and we've looked at them all already at some level or another, except for one, which I'm going to introduce now. And so we need to think about how we render our 3D. We don't want to write all those shaders and do all those buffers ourselves, so we got good old Three.js. We've got some help from Three.js and Tween.js on animating. And then we're going to now talk about an application framework I built for the purpose of this book and for my own evil needs in my consulting business, because I don't want to write that much Three.js code. As good as Three.js is, it's not good enough for me. I've built a framework on top to do extra stuff. We're going to get into that, setting up and tearing down the app. There's a lot of repetitive stuff that happens on top of Three.js. We're going to just build into a framework, does it for us. Interacting, the picking and rollovers, doing that in Three.js is a little bit painful. We'll see how painful and why Vizy makes it easier. Some predefined behaviors like spin, fade, do this kind of stuff. Not so much keyframes. They're a higher level concept than that. Under the covers, they use keyframes or tweens. And then our animation run loop and being able to pump events through so that when things happen, our application knows about it. So these, think of all these as sitting at a level above Three.js. But we also have to talk about how we got content out of this, right? Like into it, rather. And that started with Autodesk Maya model of that object and a way to convert that all out and get it into the system, including a previewer tool I wrote to make sure the model looks good before we try and put it into the app. So that's what we're going to go through. In some quick detail, we're going to go through this stuff because this is not a class about 3D modeling, but it all starts here. So I got that. Let's go back here 1 sec. You see that? Wait, where did it go? Yeah, never mind. I'm going to come back to what I was going to do later. But it all started with a Maya model, which starts with I make a 3D mesh, the shape like the teapot. I create texture maps. This sort of gives you a sense of how those UVs are generated, right? I start with a 2D image, and I draw in here the mesh that's going to map onto. And that's how those texture coordinates get generated for me in data, right? And then I can do keyframe animating in a tool like this, and I can even do sort of technical shading stuff where I can pipe shader effects into each other. These are all the disciplines that are often used in 3D modeling. Sometimes they're done by the same person. A lot of times it's 2 to 4 different people doing it. There's all kinds of tools out there for doing that. Autodesk Maya, $3,500 a seat. Autodesk 3ds Max, $3,500 a seat. Smith Micro Poser, $99 a seat. SketchUp, free. Blender, free. Range of tools. And they all output different formats, and we may be able to get to some of those right now. But let's talk about the popular ones. Anyone know what OBJ is? OBJ is a 3D mesh format. It's very popular. It only does a single mesh, but it does it well. The vertices, the texture coordinates, the normals, that's all in there, and you can put materials on those objects in your OBJ, but it's one object. It's not organized into a scene hierarchy like we're going to need. Like we saw that car that had wheels, it had a body, it had windows. That's a hierarchy of objects. You can't do that in OBJ. There's also these custom or specific, rather, animation formats for doing keyframes and skinning and all that, like we saw with the Quake models. So those are their own formats. They define a mesh plus morphs. These are text-based formats. We could read them directly into our application if we have a parser for them, but what we're going to do is convert them into something that's sort of more common than that. And then finally, there's a full-featured scene format called Collada, which I mentioned earlier. That's got individual meshes. It's got scene structure, so you get your scene graph. So you can have parent-child relationships. It's got the transform hierarchy. It contains animation data, cameras, lights, all the materials. You can take a full scene, export it out of Maya, get it into Collada. That's great. Here's one of the problems with Collada. It's XML. It's fat. It's not designed for web delivery. So we're also going to talk about a compressed version of that called GLTF. So let me go into here for a second. So one of the things Three.js does is it's actually got loaders. And it knows how to load certain formats, specifically its own. It's got its own designed JSON-based format for model data. So one of our options is convert OBJs for single mesh into JSON, and then it can get loaded into, I'm not going to show you right now because we get this great model. I don't want to get out of there. So it gets loaded into the scene. Once it's loaded, we call a callback on it, and we're going to add it to the scene, and that's all this stuff. But you know what? We don't want to load single files in OBJ form. We actually want to load this format. This is a new format that I'm working on. So I know I'm fire hosing you with information, but it's very important to understand this. So imagine you're using Maya, SketchUp, 3D Studio Max. You're able to output a Collada model, which is a full model of your scene, and you've got this big fat XML. What you really want instead is JSON, along with a bunch of binary data representing your mesh data. So for all those vertices, there's 90,000 triangles in that future Go model. You don't want that in text form. What you want is binary. So it's a compact, efficient to load representation. Your scene structure is in JSON, and there's a .bin file that comes along with it that's got all your vertex data in it. And that's called a graphics library transmission format, or GLTF. The people who did Collada, as the same people who do WebGL, it's the Kronos group, they also are doing GLTF. I'm on the committee that's doing this. I'm helping design it. And it's going to be a really efficient web format. And I'm using it in these examples, even though we're in sort of version 0.5. Yeah, so let's look at that real quick. We'll get out of Future Go and come back to this. And I want you to, when I load this, I want you to look at the load time counter on this, which will, the load time indicator will come down on the bottom left. Okay, now this is localhost, so we're not taking into account the transmission time over the wire. Oh, you might not be able to say that. 0.31 seconds. Back to Steve Suter's responsive web pages, web performance. Whole page has got to load in 2 seconds. Well, if takes 0.31 seconds for the model. I don't know why this is jagging on frame rate here. Might have to reboot, or it might be the monitor again. It's usually smooth. That 0.31 seconds gives you a hope that you could load content like this quickly. And if you run server-side compression, you can get this model to load pretty fast and still have your page load in a couple of seconds. And so I wrote a little scaffolding to load GLTF files. I can change different models. I can basically look from a different camera point of view, right? Tumbling. Again, I don't know why I'm janking on that stuff. Usually not an issue. I think it's the 2-monitor setup. So apologies for that. Let's go to default camera. You can see a bustling city here with a bunch of objects moving around. Woohoo! Yeah. So this was a 3D Studio Max file I bought from online and was converted through Collada, exported out of the modeling tool to GLTF. And that's the same technology we used to do the Future Go. And that's the pipeline. But that's just the beginning of all this stuff. So let's talk about, that's how we get content out, but now we got to talk about how we actually program it. So I'm in the wrong folder. 1 sec, sorry. Here we go. So that's cool, but I mentioned this other thing, which is really important here. Three.js is great, but it's really just here to give us rendering so that we don't have to do all that hard work. But what it doesn't do is really help me with picking events, with triggering animations and behaviors, with doing the set and tear down of the scene. Even something as simple as when I resize my page and the canvas resizes, you have to handle that and do that in code in Three.js. And you look at the myriad Three.js samples, and it's always copy and paste of the same 20 lines of code for all that setup and tear down. Why not have a library that just does that for you? Because it always happens the same everywhere. So I created this thing called Vizy to do that, and it's a framework like this. And you know what it's like. You guys use frameworks every day to build apps, right? They're frameworks. You love them, you hate them. I mean, for me, I love it as long as it's mine, right? I don't know how you feel about that, but every new framework is a commitment. It's an obligation, and it's a Faustian bargain. You're getting functionality in exchange for loss of control, right? But in this case, I like my Vizy framework to show off how you can do more work faster with Three.js. You could use a game engine. There's a bunch of them out there for WebGL. Some are free, some are open source, some they're trying to make money off you. Go look around, use these URLs, search them. The examples are great. The graphics are breathtaking because they've done a lot of work. And some of them don't use Three.js to render. They've got their own renderer in them. I mentioned Vizy, this presentation framework. It's more along the lines of this stuff. Easy to put a model in a page. Easy to get going with stuff. It's not a full game engine. And here it is. Who's used Unity 3D to build a game? Anybody? So Unity 3D uses modern game engine design principles. Very sort of well-understood game architecture. It's not object-oriented and class-based inheritance. It's components. So you have entities and components, and an entity can hold a bag. It's a bag that holds components to do different things. So it uses that inspiration. It also has pre-built functionality for application setup and tear down. It handles the mouse interactions for you and comes with canned behaviors. But it uses Three.js to do all the graphics. I didn't want to reinvent that stuff because that's a lot of work. You go look at what's in Three.js, it's tons of stuff. So you've got this information here. If you want to just go play with Vizy and its own examples, some of which duplicate the stuff we're seeing here, others of which are new things, like an attempt at doing Oculus. Will be in there pretty soon. Go clone this repo, and all you really need to do is bring in this because it also has Three.js built in. There's a build option where you can build it without the dependencies, and it won't have Three.js in it. But this, if you just take the whole package, it's got it all sort of built together, plus Tween.js, plus a few other things like the Collada loader. And so now, instead of, the cube would get even simpler. The main part of the cube thing is kind of similar to what you did in our Three.js cube example. But let's say you want to rotate it. You just add a rotate behavior to it. You don't need to do this thing of changing its rotation property all the time. It's another component you just add. And then we add a light to the scene. That's just Three.js stuff. So it's just like the Three.js example at the level of constructing the scene. But the power you get is when you want to start adding behaviors and interaction. So we're going to look real quick. So there's a Vizy cube rotating, and it's just the rotate behavior. So that thing's replacing what we were doing before with a keyframe around the Y or programmatically doing it ourselves. And how does that work? The magic is it's a component, it's added to an object, and it says, I'm going to go up to my parent object. I'm going to get its transform. The thing I know has got its rotation and position, and I'm just going to do that myself every time you call my update method, which happens by the Vizy framework every time through your run loop. Easy peasy stuff, and you start combining these up, and it gets really fun, and you can start composing things up, and you can have a rollover trigger that triggers a behavior. Let's just look at that right now. Right? Mouse over, rotate. Mouse out, stop rotating. Right? And that's easy peasy because I invested the time into the code to do that. So how do we do it? We create another kind of component called a picker. And we add event listeners just like we would in the DOM. And those functions will get called whenever the mouse is over that thing and out. Under the covers, there's a lot of stuff going on here. OK, where's the rotate behavior? Oh, I created the rotate behavior again, but this time I didn't have it auto start. So that's why the cube wasn't rotating until I moused over. That was the only difference there. So I've talked a lot about this before. Without that kind of framework stuff, this is what you have to do in Three.js to figure out if your object's picked. You have to go through, create array going into the screen. I think someone was asking about this already. No, that was yesterday. Sorry, I'm starting to lose it. When you do picking on a 3D scene, if you think about it, it's a 2D mouse position, right, on the viewport. You've got to figure out what objects it's over in 3D. So remember how we talked about the projection matrix that turns your 3D scene into flat pixels on your 2D surface? We have to do the opposite operation to figure out whether something's picked. And we have to go through this and create a raycaster from that point on the surface of the screen into the scene. And so it's a real 3D ray now. And we see if it intersects the objects in the scene graph, in the Three.js scene graph. And when they're intersected, we do that, we find that, and we've got a whole list of things now that's been picked. Well, that's a whole bunch of garbage to go through every time you want to see what the mouse is clicking, right? So the Vizy philosophy is add a picker component, and we'll do all this for you in your scene graph. So you don't have to think about it, and you'll just get an event listener, and it'll tell you when it's picked.
What's the performance cost on that?
The performance cost on doing this is it's being done in CPU, right? And what you're doing, though there are GPU-based techniques that are a little advanced and weird for trying to do it in the shader, but I don't want to get into that right now. Typically, the way you do picking is you're doing this math against a certain number of objects in the Three.js scene graph. Three.js doesn't have too much optimization around this. It will do things like if your ray does not intersect the bounding box or the bounding sphere of your mesh, it throws that whole mesh out. It doesn't search it anymore, right? But if it does intersect the bounding volume of your mesh, it now goes through and sees which triangle was hit. So in the 90,000 triangle case of my FutureGo model, when you roll over that, it now goes through and tells you, which triangle was clicked and which point on that triangle in the mesh was clicked. And it does that by linearly searching all 90,000 triangles. And you don't even see the effect of that on the screen. Because rollovers just work. When I move this over to mobile on the Kindle Fire HDX with a slower CPU, whenever you tap on that part of the mesh, you'll see it a little bit. There are techniques for accelerating that. You can sort the triangles into something called an octree. So now instead of a linear search, it's a logarithmic one on base 2. Awesome. Requires a little overhead when you load the model to do the sort. Three.js doesn't have those picking techniques wired in. So one of the things I've thought about in the Vizy framework is to enhance this, use a different set of picking tools instead of what Three.js gives us, and do some of that geometry sorting, but haven't gotten to it yet. So that's a great question, and it can be prohibitive. You've got to be careful there. And then I've got another example where you can add more than one behavior. You can bounce, change color, fade. And so I use these all to then construct an application. Let's go to the one last piece of this workshop here. Great, yeah. So, you see this? Wait, hold on. Yeah, just checking. Yeah, I'm right. That's a screenshot of the app, right? It's actually not. This is a comp my artist TC did in Photoshop. Almost indistinguishable from the live app. Let's go back and look at the live app. Thank you. You're so sweet. Looks worse than live app. It's a pre-render of that model out of Maya, comped together with a bunch of stuff in Photoshop. And that's what we used as our guide to build this app. Well, yeah, I mean, the grid's in there, too, which was a happy accident. The grid came from when I have a little previewer tool, which we're going to see in a second. And I accidentally forgot to turn the gridding off in the little viewer. And I was like, that looks really good. I'm going to keep that in there. So that may be one reason why you're saying it looks better. The only actual difference that you can notice with the naked eye is that Futura is not a Google Web font. This is PT Sans. It's actually just the text font. It came closest to Futura, which is what TC used in his Photoshop. I mean, otherwise, it is pretty hard to tell a difference.
I mean, this doesn't have like the lighting in the mock-up. It doesn't feel like.
It's not as pronounced. You're seeing the lighting in the mock-up's a little bit more pronounced, right? Or are you saying it's better in the live version?
Yeah, I think it's better in the live version.
Well, that's funny. I think that's a matter of taste because this is a pretty well-rendered Maya model. I mean, probably took a second to actually do the render. So it's funny, you like the real-time lights better. Yeah, I mean, that's a matter of taste, I think. So anyway, we started with that concept. There's the model in Maya. Looks pretty close to what we're talking about here, right? A four-view, typical thing. And then we exported it. And again, we're going to export it to this format we know about Collada. Then we're going to convert it for deployment into GLTF. But before we do that, there's a very important step. So imagine now you're about to build your first 3D application that's using model content like this Future Go we saw. And I don't know, maybe you bought it off of a site. Maybe you contracted someone in another part of the world to build that model for you. You gave them some specs about polygon count. You gave them a mock-up, drawing. This is what it looks like. They build this thing for you. And they give you a file. And you say export it to Collada. Now they give you a file. And you don't know what the objects are in that file. This is an interactive application we're building. We need to know what the meshes are called for the different parts, like the windshield, the body of the car, the wheels, the names of the animations. So no offense to anybody of the modeling persuasion. I don't know if anyone in the room actually uses a modeling package. These are people that are notoriously bad spellers. They don't always model things in inches or feet. They model them in angstroms or some bizarre, completely arbitrary coordinate system. It's especially true if you bought this thing off a third-party site. So what you need is a set of tools for looking at this stuff before you actually try and put it in the application. Because if you do it and you try and deploy it in the application, your development cycles are going to be a lot longer. You're going to go through a lot more pain. So I use this Vizy framework I've been touting to create a previewer, just a little tool that I wrote. Now, if you go to one of these other engine companies I was talking about, Goo, Veril, these people that make these game engines or content creation tools, you'll get great preview. They'll let you upload models and formats and do all that stuff. They may or may not give you the source code to their engine, though. They may or may not let you deploy it on your own site. They may be trying to host it so they can make money. They can make money somehow. They got venture capital investors, right? Well, this is just code I wrote, so I control it, and you guys could build your own previewers like this, too. And I mean, God help me, that's awful. That's jQuery UI stuff. It's garbage, right? But you could build a better one with Angular Bootstrap or your favorite UI framework. But the point is, it's got a model view and a Vizy.viewer object in it. We're going to look at it right now. And it gives us a way to take a look at this stuff before we try and put it in the app. So I'm going to open the Future Go model, which was exported out of Maya, converted to Collada, and then with a command line tool, converted again into GLTF, which is compact JSON, and the 90,000 triangles in here are in binary format. And the thing about the GLTF binary format is it's those typed arrays. They come down the wire as a typed array and fed directly to WebGL. No additional processing. You don't have to parse JSON. You don't have to turn JavaScript number array stuff into the typed arrays. It immediately loads, which is why that somewhat complex scene with all those animations, those spaceships flying around, that's keyframe animation, lots of positions, rotations. That's a stream of binary data that came in untouched. And so I get this little viewer that lets me basically do a free navigate because I've got a built-in Vizy viewer object that says, OK, when you wave the mouse, it knows what to do. It rotates the model. Otherwise, you'd have to write a lot of Three.js code to do it. This thing knows where the cameras are. I'm double-clicking on it and just checking the different camera views. Hey, I can go inside the car. I can turn the various lights that came into the scene on and off. And now that helps me see one thing. There is some ambient light on this model. I mean, there's no other lights in the model, but I can see a little bit because those materials have a slight ambient component to them. But, you know, I also have this little utility here. Oh, this page is a little crammed. Sorry about that. I can turn a headlight on. So now there's a light that the Vizy previewer added to the scene. So I've got a lot of ways to experiment, including this gridding I was talking about, grid on and off. That was a happy accident. Again, it really enhanced the final presentation. So very cool. I now know the names of these animations so I can trigger them. Oh, I'm going to, you know, open the front window. I'm going to open the rear window. All right? Very cool. I have everything I need now to bring this in to the app I'm going to build.
These animations are in the file?
They're in the file, yeah. So let me reiterate. So because we used the 3D modeling packages, the pro ones at least, well, pretty much all of them, they give you a way to make your meshes, but also to do keyframe timeline animations. And then you build them in that tool. So an artist built that animation of the window flying open. We didn't do that in code. Artists did that. And when we saw those spaceship animations, the cameras and all that stuff that went with that, and the little vehicles moving around, an artist did that, made all the keyframes for all that stuff. And it was keyframe data, like we've been talking about in the morning. Same stuff, right? So all of that was exported to the Collada format out of Maya. And now you've got an XML-based representation of meshes and animation data and lights and cameras and materials. But then again, for efficiency, what we did is we ran a command line converter on this thing so that it turns it into this GLTF format. I'm going to need, would you hook me up a little water? Got another cup over there? I'm starting to frog out a little bit. And so the GLTF conversion step was just the batch line command converter that comes. This is all open source stuff. The links are in your slides. You grab that, you run that on the Collada file, and it turns it into a JSON wrapper that has the scene graph information, so the hierarchy stuff we talked about, parent-child objects, names of meshes, names of the animations. But then all the data, the 3D vertex data, all this complicated stuff is just in a binary file. But yeah, the source of that originally was the Collada file, which had all that information. And you know, a lot of people showing off their cool WebGL demos to date, they didn't do it that way. They took these single model OBJ files and they reassembled them in the scene using code. It's like literally the artist is like, hey, Steve, you know, like can and some string. Hey, you know what? Oh, yeah, put it at position 17, whatever. I put the camera here. I use the light of this value. I mean, that's how they're doing it. They're exporting OBJs and then hand lighting stuff in text, you know, in a text editor. Doesn't make any sense when you've got artists who know what this should look like. They can position, orient, place everything, and animate it. So we have a lot of content using these formats. We can get a lot of content into the system without a coder having to touch it until it's time to do a special effect or a behavior, right? Go ahead. Question?
Yeah. Is there a way to, let's say, substitute a low poly model into a high poly one when you're ready to export to?
So when you're ready to export something like this, if you wanted to generate it lower poly, what you would do is inside the modeling tools, they have what they call decimation tools right inside there, and you would tell the modeling tool to give you a decimated version. You would still be looking at it to make sure it looked OK. And what you might do is actually export multiple levels of fidelity for a model like this, starting very high, higher than the 90,000 polys possibly. And you could export multiple resolutions of that into the same file or different files. And if your application knows what to do with it, it could select based on, say, the footprint of what you got if you're running on a phone versus a laptop. If you're bandwidth constrained, maybe deliver less information. Maybe it delivers them all and preloads them all and does a technique called level of detail. As your camera moves farther away and you're going to see less pixels on the screen, it could actually just literally swap it out and use the lower res model when you're farther away. You can do all that in code. These are techniques that we're free to explore with the tools we're talking about. So great question. So yeah, so we then create the page. And it's really as simple as just laying out elements like I've been talking about. You want to make sure your z-index for this guy is a smaller value, a negative value probably, than the z-index for these guys, so they appear on top. That's the only trick there. Oh, and again, isn't this nice? If we look at the CSS for this, you'll see that just the background image property is what's being used to paint this gradient. How awesome is that? You don't have to render that in 3D or anything. Browser does it for you. So then, now that we know what those animations are called, we just use the Vizy frame, and we previewed it. We use the Vizy framework. It's got a built-in object for a viewer. What that thing does is not only it will present the model at the origin for you once you've loaded it and added to the scene, but it gives you this capability of dragging it with the mouse to rotate, zooming in. This is a lot of code to write on your own in Three.js. Three.js doesn't even come with a built-in one in the base package, but in the samples, there is something called an orbit controller. That's what the Vizy viewer's rotation is based on. We actually brought the orbit controller. It's an extra. It's not part of the Three.js package. We brought it into Vizy, put Vizy component wrappers around it, and this is our top-level application, and it's got the run loop. All right? So we call load URL on whatever our URL is to the model, the 3D model. It's going to go do that in the future real soon. It's going to start loading it now. We're going to get a call back when it's done, when the data is loaded. And then we say run, and it goes into that run loop. That's request animation frame. That's render the scene again from Three.js under the covers. That's calling Tween.update in case you've got any Tween content in there. Doing that all under the covers for you. Load URL does a couple things. Creates a new loader object. It's a Vizy object that knows how to load different files in different formats. Collada, GLTF, OBJ specifically. And we're going to create a loaded event listener that is going to handle the load by basically just taking the data that was loaded and replacing the contents of the viewer's scene. There's also an add to scene method instead of replace, so you can start with a scene and then add extra objects into it. So you can basically stream objects in over time. See, this is all stuff I wrote that's capturing design patterns of stuff you're going to do a lot. You're going to load a scene. You're going to add stuff to it over time. You're going to fiddle into the scene, find the named cameras or named animations, and trigger them based on behavior, such as this. You're going to add a few flourishes. I don't know if you noticed. Let me reload the page here. It's part of the fun. Watch what happens after it loads. You see those windows fade? So I created a few built-in behaviors, and these are just sort of ad hoc and whatever I felt like at the time, but they're just other Vizy components. I make a new fade behavior. And what am I doing here? This is some trickery. OK, we don't have jQuery, so I can't use CSS selectors because at the moment, these aren't DOM elements. If they were DOM elements like my talk yesterday, this would be replaced with a selector in jQuery, right? So my version of that right now is I happen to know these objects were named Windows Front and Windows Rear. Thankfully, TC does know how to spell, and he told me what the names of those things were because my previewer didn't have the capability to tell me what that model was. Not yet, anyway. I made a new version that's got that. So the name of that front piece of glass is that in the file. It's literally in the file. That's the ID of the object. The name of the rear piece is that. So I'm going to take both of those and add a fade behavior to them. That's a 2-second fade, which goes from full opacity to 0.8 opacity, so we can see through it a little bit. We add that to each of those objects, add that fader to each of these O's, which is, where is it? Passed in here through the map function. So this is just like basically doing a jQuery thing where it's applied to a bunch of elements based on a selector. And then after 2 seconds, this is where set timeout's totally fine, by the way, right? We're just saying 2 seconds in the future, call this function. This function's going to call the start method on the fader and trigger the behavior. So it doesn't happen until 2 seconds after the page loads, by design, because I wanted it to take that long. And then the other thing we do is we're going to add rollovers, right? So we get a mouse out, it does something. We get a mouse over that does something, calls these helper methods. Remember how when I rolled over it, we got a div? It told us about the component on the page, right? That's the magic. There's a picker component in there that's generating mouse over and mouse out events for me. That's the way you want to start. This is how you can get to scalable development on this stuff so you can get there faster, right? If you don't like the Vizy framework, build your own. Like I said, I like it because it's mine. But I wouldn't blame you if you don't use it. And I'm not encouraging you to use it because if you do, then I'm going to have to provide you tech support. And I don't have time for that yet. But if you want to use it and contribute to it and build something cool with it, I would love that. Just talked about that. Those animations on the thing get, when you click, there's some helper functions in Vizy which plain named animations, literally passing the names in. So for the window opening, I'm doing it this way. And then I've got another trick, which is the keyframe animator that's built into Vizy for doing this stuff. Can play these in reverse. And that's literally reversing the animation is this third argument here. Saying play it in reverse. That's a nice trick. How do you think it reverses the animation? It's a keyframe animation, time series from 0 to 1. What do you think it does?
1 to 0.
Makes it from 1 to 0. And the keyframes just work backwards. It's one line of extra code. It says if it's reverse, flip the value. I love JavaScript. This was really cool. I didn't have to build that color picker. Thank God for open source. The jQuery, add-ins. You say $element name color picker. Boom, when you click on it, color picker comes up. You have to feed it a few callbacks and other things so stuff gets wired up. And then basically what we did is we figured out what colors we're going to change. We went through the body of the model here, which happens to be these 4 objects, right? Those are the ones whose materials we're going to change. We put them on a list for now, and then when you start sliding on the color picker, we're going to just change those colors. Oh, so I was going to show you the code for that real quick. Let's see. Picker. Okay. So when it changes, set body color. That's probably in future go.js. So color picker gives me RGBs, range 0 to 255. I got to convert them to floating points because that's what Three.js knows about. And I basically go through this list of materials on the object for each object. Sometimes a mesh in Three.js can have multiple materials on the same mesh. So I wrote this code that says if the material is an array, go through every bit of that. If it's not, if it's a single object, go through this. And we just call the setRGB method out of the color. And voila, the colors change. Fantastic. So what have we seen now? We've seen that you need a modeling tool to create this, or you need to get a model from somewhere that has this kind of data in it. You're not going to do this in code. We looked at some pipeline tools for actually getting that data out. That world is still evolving. I mean, not only, so the GLTF format I mentioned, we're developing that in real time. It's all happening out in the public eye. If you go to gltf.gl, you can see the latest versions of everything. I wrote the GLTF loader for Three.js. If you go get the latest Three.js, you'll see my dirty fingerprints on the Collada loader. I fixed several bugs there. I went in a year ago doing a project with Collada models. Great. Where are the lights? I go in and look in the code. It's a comment, lights, TBD. So I wrote the light parsing, figured that out. Had a few of those things I did. Then when GLTF came along, I said, I know the ins and outs of this stuff in Three.js. I'll write the GLTF loader for it. But guess what? There are 3 other GLTF projects that are non-Three.js viewers and loaders built by 3 other people who are working on this team with me. We're doing it all out in the open. There's lots of examples. The main point is, again, we get this compact format that'll get delivered to a phone over a crappy little network fast. Because it's really compact data, and it's got all the scene data we need in it. So that's really cool, but it's still a work in progress. These tools are, the converter tool from Collada to GLTF it's one guy maintaining it. The export to Collada for Maya and Max it used to be really broken. There's been a project called Open Collada to fix those things, and that's made several improvements to Collada. So You don't just go, say, export FBX Collada exporter, the thing built into Maya, if you're a Maya user or a 3D Max user. That's Autodesk's exporter, and it sucks. So you have to go get the Open Collada exporter. There's a whole cookbook for this stuff. Once you've done that, you need a previewer tool like I showed you. Otherwise, you're just flying blind. It's like, where's my model? Why didn't it show up? What's the thing called? Where are the lights? Do I need to turn lights on and off? How do I fade this thing? So we've got to have some previewer pipeline tools. Either we build them ourselves or we make a deal with the devil, use somebody else's framework, use somebody else's online development system, GUI technologies, Veril technologies. These guys are listed in these slides. I encourage you to test them all, try them all. Just remember, unlike me or Ricardo, they all want something from you, okay? They want to get paid. They need to. It's a business. We understand that. So be careful. But if you can use one that gives you the source code, doesn't force you to host with them or demand some other tithe, then by all means use that. Don't use mine. I just did this for the book and my own projects. But finally, the net result of all this is, look, we got a 3D model in a web page with rich interaction. The stuff works together seamlessly. Thank you, WebGL. Thank you, Ricardo. I played a very small part in this with Vizy. Most of this is standing on the shoulders of the giants who built the browsers in the first place and made WebGL. If you go further and use my book and the examples in it, you'll see that this was chapter 10 in the example set. Chapter 11 takes the future go and brings you into a virtual city and lets you drive it around. I'm just going to show you a demo of it. We don't have time to walk through all the code. Welcome to Future Go City, the city of the future. What I really wanted to do, I didn't have time for, is to have zombies sort of popping out every once in a while, menacing you. That would have been more character animation, more Collada wrangling, and stuff we didn't have time for. I was trying to illustrate a few other techniques. The first of which is, instead of a model controller, instead of being able to orbit around the model, now I'm doing mouse look like I would in a first-person game. This is first-person navigation. I'm using the keyboard, arrows, WASD, W-A-S-D, like I would in a video game, using the mouse to tilt the camera. The second technique this illustrates is this background here looks like more buildings. It is more buildings, but it's actually just a 6-sided cube skybox. It's an infinitely far away box with 6 texture maps on it. You never get closer to it, which makes it look like a big city. Of course, if you keep going, you might see that you can look over the edge. I put a box in here so you collide with it. There's a little collision detection on the navigation. So you can't fall off the edge, but you can see that when the geometry ends, the illusion breaks, right? Pretty cool. We built an advanced version of the previewer for this chapter where I not only can look at the animations by name and everything, but I can see every building. I can pick on it, figure out what the name of that node is. We're actually adding, see that skybox background? You notice how it's reflected in the buildings? We're using that environment map technique. Remember the sphere with the cloud background on it from earlier? That's an environment map. It's just the same textures. Looks like the building's reflecting those other buildings, right? Great, cheap cinematic trick. I hit the Start Test Drive button. I pop inside the Future Go. We do one of those fade animations so I can see out the windows. I now have another controller that uses my mouse. I can still use the keyboard. I can still use the mouse to look around, right? But now the keyboard's controlling the car. Remember we talked about this with the, animating the textures? That's Canvas API code. It's drawing a background bitmap, which is the gauges, and then it's moving the dials based on your RPM and current speed. Notice how it went up a little bit? Let me see if I can drive backwards here. No, can't drive backwards. Notice how I just went down? I'm going to reload because I went off the edge here. One more time on this one. I'm going to show you a couple more fun features. Colliding. I can't go through that building. I can if I work hard enough at it because my collision detection algorithm is bad. Watch this. Notice how I went up and down on the sidewalk a little bit? Did you see that? Terrain following. So every time the car moves, we cast a ray straight down. It asks the question, is there anything below? If there is, what distance? How far away is it from where I'm casting the ray? Is it the preferred distance I want to be at? If it's less than that, then I've intersected something like a sidewalk. Move me up. so I can stay at the same distance. If it's below that, because I just went off the sidewalk back onto the ground, it knows that it's longer than that preferred distance. Move my object down. That's called terrain following. In its simplest form, implemented with a single ray. The collision detection implemented with a single ray that casts a ray from your eye point and says, if I hit that building, stop. Now, the problem is it's just your eye point. So if you had, let's say, a wall 2 feet high, and you intersected that, and you said, I hit the wall, like, and it's in front of this, you wouldn't hit that wall. You'd hit the building here, and you'd go through the wall, because you're just using a ray from your eye point. So what most game engines do is they take a whole cylinder, they approximate your body, and collide that, right? I didn't do it that way. This is cheap and dirty, quick collision detection. All by way of illustrating, yeah, you know, we're not only doing single objects, we could do virtual environments too, without too much extra stress and too much extra hassle in the preview. You know, and I apologize, we don't have time to get into all the details on this one, because this was really fun. This is actually the longest chapter in the book. It's like a 45-page chapter. At least when I was doing it in Word. I don't know what it turned into when we printed it. And there's a lot going on in here. All those animation techniques, collision detection, skybox, environment maps. I probably missed a few. We're going to do a quick break, and then we have one more segment planned. Do we have any questions or thoughts or reactions at this point? I know it's getting tiring, and there's so much to go over, and there's so much information. If there was well, I like to pride myself on thinking about, first and foremost, what do people need to do to try and get something built? And something that's real, not just a toy, not just a cube spinning around on the screen. And to do that with 3D, unfortunately, because it's such a complex discipline, we needed to cover all the stuff we've covered so far, I believe. If there's a simpler way to teach this that gets us to the point of a practical application, I'd love to hear it. And I'm sure there could be ways to improve this, but unfortunately, there's just a lot of material to cover between graphics, animation, interaction, the tools, all the specifics of the APIs. So I know it's a lot. I know you've been fire hosed in a lot of ways. When we get back, we're going to look at what it would take to get some of this stuff running mobile. So if you got the patience for that, and then anyone who wants to stay after for detention, we can go back and look at CSS3. Or not, we can go offline with that. But if you got the energy, let's do one more half-an-hour segment on mobile. But let's take a 5-minute bio break, 10-minute bio break first. Take your time. Don't rush back. Based on what we're hearing about WWDC, but we don't know for sure. So WebGL supported almost everywhere. CSS 3D is supported everywhere. We didn't cover that today, but if you want to do simple 3D page effects, spinning elements around, twisting them and rotating them, you can do that. Canvas is supported everywhere, so it is always your fallback, but as we saw, we've got some limitations on how well we can render, how much we can render, and how fast we can render it. So let's, for this purpose of this section, just talk about WebGL, because that's what the most exciting part of this is and the most capable. So WebGL works great on Android browsers these days. Shipped in the box. If you've got an Android phone that's fairly recent, it's going to have WebGL support in it out of the box. If you've got an NVIDIA Shield, one of those handheld gaming things, Android-based, it does it all amazingly. 60 frames a second, great graphics. This is the Kindle Fire HDX. This is an Amazon, Android-based device from Amazon. $229. It's a steal of a deal, the best multimedia device on the planet for the price. Let me get to my wireless settings here. So you have to actually get on the Wi-Fi to show this. SVW was the code, right? Chrome on Android, Firefox on Android, vendor-dependent browser on Android like Amazon Silk, which I'm going to show you in a minute. Actually, yeah, I was going to run it in the web app tester, but we'll get to that in a second. So I'm going to launch the Silk browser on the Kindle Fire HDX. That's Amazon's WebKit browser. Oh, and it's got the URL to FutureGo right here. And here it is. I didn't have to make any changes. The screen's a little cramped. I'm stupid at responsive design. There's no responsive code in here other than making sure user scrollable or whatever is turned off in the meta tag, in the viewport tag. That's running pretty much same frame rate as on my desktop. I didn't have to touch that code. This is the Silk browser just hitting the URL that's on my Vizy site for where these examples are. I did have to add some code to do the touch events in the viewer to do that when I swipe. And there's no rollover, there's no mouse rollover for those divs. But if you tap, you get the same information on the same spot. And that's with touch events. So I enhanced the Vizy framework from its original mouse handling to also support touch using browser touch events. This is browser standard stuff these days, right? So all the things you can do like tap and tilt with an accelerometer and all those things that you used to have to use PhoneGap for, the browsers all have events for this now. Don't really need to do that. And so that's kind of amazing. And that's the good state of affairs with the Kindle Fire HDX. But, of course, that's one device. And it's one great one from Amazon. And, again, the NVIDIA Shield, handheld gaming with controllers built in, an Android phone and everything, blah, blah, blah. Great. But there's a variation of speeds and performance profiles you've got to be really aware of. So they're not all going to perform like this. You've got to think about that. JavaScript performance, when you're going browser-based versus, build a WebKit-based app, it's a different deal. If you're running in the browser that comes with the phones or that someone's made for the phones, you tend to get into situations where maybe the browser won't JIT compile for you. You've got a slower CPU in general. This is a cheaper device than your desktop computer, right? Of course, the GPU itself may be smaller and cheaper, which I didn't highlight, but I mentioned in the first bullet. So, maybe not only that, but it depends on the size of your screen, right? I mean, yeah, this thing's supposed to do 1900 resolution, but you can get away with low res stuff. Maybe you ship less content. Data challenge network, right? Think about that. Especially if you're going on a phone here. Why are you going to waste all that content if you don't have the resolution to see it? So you need to think about that too. Get a smaller content footprint. Maybe you're delivering things at a lower level of detail like you asked me about earlier. And even still with Android stuff out of the box being browser-based and just working because of these JavaScript issues, no jitting maybe. Maybe you want to look at a hybrid solution. The way you do PhoneGap development where you've got a combo of HTML5 and some native libraries to either fill in the blanks where the features aren't there or accelerate things. Then we can look at a hybrid solution. And it's the way we have to do it in iOS today. We're going to talk about that at the very end here. But you might also want to do it in Android. So think about this combination of my app's in HTML5. I've got my rendering code in WebGL or Canvas. All that logic's in JavaScript. And yeah, that's going to be my most fast, efficient way to build the app, especially if I'm a web dev today. And it's cross-platform. It's the same code running in my browser more or less. Sounds like a very promising strategy if combined with a few extra native libraries to give us the push over the top for performance or to get at that feature of the device that maybe isn't in the browser APIs yet. So I showed you the HDX. There's a version of the samples that has the touch events enabled, just like I talked about on the HDX already. So it's a slight adaptation. Mostly just added code. I don't think I changed anything else. And I did this really evil hack. So again, this orbit controller thing comes with the Three.js samples. So when you drag the mouse, will spin. It doesn't even spin the model. It moves the camera around a virtual sphere orbiting about the model. Well, it didn't have touch event support. So I did a hack, which is basically I'm going to handle the browser touch event, right? I'm just going to grab I'm assuming single touch, right? And what do I do with it? I just hack an event together and pass it onto the code, which if they, that's not very robust. If this code actually expected a DOM mouse event for real, this thing would crap out because it's the wrong type. It's just a JavaScript object I cooked up. It was a fun hack, though, really easy to do. So that's how I added touch support so you could swipe the future go. And I got to do that in 2 hours instead of God knows how long it would have taken otherwise to do it right. But then on the Vizy side of this, when you want to get the pickers and know what's going on, the application needed to know. You don't want to fake it out and tell it was a mouse event when it was really a touch event. Because maybe the app wants to know. Maybe it wants to do pinch, multi-touch stuff, right? So I just added some event handlers to get this to work in Vizy. So you can have touch start, touch end, touch move. And it basically gives you the events with the touches list. You guys know the touch APIs in the mobile browsers. They're basically a list. You get an array of touches, one per finger. So you can detect, you can detect pinch and zoom kind of stuff. What you do is basically grab your touches in your array and track them in every frame. The next time you're through there, as you get a touch move event, you can calculate the distance between your two touches and know that things are either being pinched in or out or swiped. Oh, yeah, this is pretty cool. So that's pretty straightforward. Now we get into some interesting territory. Who's ever tried to actually build a mobile app and debug it on desktop Chrome? Or debug it with ADB talking desktop Chrome? Yeah? So I don't want to get into the details of setting up ADB. So ADB is the Android debugger. And it'll talk over the wire to the actual device. And so you can interactively debug on board on the device. You have to do some setup for that. There's a bunch of horseshit involved in doing that. A lot of documentation from the vendors. You got to port forward. There's things you have to do, right? Don't have time to get into them here. One of the things you can do, though, before you even get to that is pre-test a lot of this stuff by doing emulation in browser. So let me open this up in Chrome.
Also, now you can do USB plugging Chrome on mobile, so you can pull up it using Chrome on mobile, and then.
Don't you have to port forward with ADB and everything, though?
Nope.
Really?
Yeah, you just do Chrome://inspect, and it'll tell you what USB devices it. And it'll show you that your phone what tab there.
And you say connect to it, and it all just works?
Just enable USB debugging on your phone. Yeah. So if you go to Chrome://inspect.
Let's just do that right now just to see this. I didn't know that.
If you plug in your phone and click Discover USB
Yeah.
devices, if you plug in your phone and it's on debugging mode, it'll pop up with whatever tabs are open.
So it's essentially doing the ADB port forward under the covers, and you don't have to tell it.
And you can press inspect and it'll pop up with the Chrome. Okay.
That's very useful. Right after we get out of here, I'm going to go look at all the details of that. It's great. Did not know that because it's a bit of a hassle otherwise. So why don't we see what emulating the Kindle Fire HDX, will look like. I open the Chrome debugger. This is Chrome specific, by the way. I hit escape. Now I get an emulation panel. I just hit escape, and my console output contents get replaced by this. And I'm going to say I get to pick my device. So it's basically a form factor. Excuse me. I don't know what else it's emulating besides the aspect ratio and everything under the covers. I don't know if anyone knows. Please volunteer the information. I hit the emulate button, and there's a glitch in Chrome right now. I actually have to hit page reload to get this to look good. And now, you see that circular cursor? That's telling me touch events are being emulated. So now I'm getting the touch. I don't know if it's being reported in the console. Let's see. Not for the model viewing, but maybe for the, yeah, there we go. See that? Touch start being reported to the console. I just put a console.log in the Vizy picker callback for this. So it's not using the mouse event. It's not faking a mouse event. I'm getting a real touch event that the browser is emulating for me. So that's pretty good. The other cool thing about this debugging is, let's see, sensors. So that was the touchscreen sensor. If you go to the sensors panel, you can only do a one shot of this. But if you want to do device orientation stuff, I can't show you this example. It's for a customer and it's private. But I have something now where you're in a virtual room and you can look around it just with device orientation, tilt the camera, use the accelerometer to figure that out. You can emulate those by jamming in a device orientation data into the alpha, beta, gamma values here, if you know that API. But it's a one-shot. You're just setting the value, and you could move the camera based on that. There's no support for this in this app, so I can't show it to you. But it's another nifty thing. You can get the accelerometer. You can emulate lat long, as if your geo APIs told you where you were. Again, one shot. That's pretty cool. So that situation's better now. You combine that with the ability to straight USB debug, which who knew? Well, obviously you did. It's great, right? And there's my touch start. We talked about that. But that's browser stuff. Most of these guys also give you the ability to create a web app, which is essentially packaged up browser stuff with a manifest file saying what the contents is going to be. Come on. And you run that, and Amazon has a web app tester, which you can download from their site and have a URL to it. Just gives you you put in a list of URLs, you hit it, and it basically tests the packaged app for you. So what else do I have in here I can show you? It's another version of the future Go via the web app tester. It's exactly the same as what I saw in the Silk browser. But once you're happy with this, you create the manifest file to package the app. And you can deploy it through the Amazon store. You've now got an app which can have an icon which appears on the Kindle Fire desktop. And now you have the privilege of paying Amazon's App Store. Anyone go to that talk yesterday of the death of the App Store? I was at that one. That was really fun. Some dude from Belgium was saying, look, this is all URLs the way you share things. What is this discovery nonsense through the App Store? It's all going to go away. People were a little skeptical. I mean, it's a compelling point of view on this that eventually he may be right. I don't think it's going to happen tomorrow, especially through Apple. But
I remember several years ago when the iPhone started to explode, the opposite was said, that web programming is dead. It's all going to be apps. Everything's going to be apps going forward.
I would never bet against the World Wide Web. And to actually do that packaging, has everyone ever made a manifest file? I mean, it's just a JSON data structure that lists what your app package content is. Every vendor's got a different one. This is a compare and contrast between Amazon's developer portal, get this information here, and Firefox's, which they call the marketplace. And what do you say? Basically, you need an API key, or not an API key, but an app key you get from Amazon. You put it in here. You say what the root file of your app is. Index.html typically could be whatever. You can put some permissions on there. Hey, is this app allowed to do geolocation? Type and version number, metadata for author. Similar here, just different syntax, metadata for author. Oh, app icon. I don't know where that is over here. Maybe I just missed it, but it seems like you want that for Amazon too. You can list which orientations are acceptable so that they don't auto-orient if you don't want them to. Locale information. Where can I install from? I have no idea what that means. You can look that up. So you can do everything you just did, package it using a manifest, upload it to the store, and again, then have the privilege of paying somebody if you have an app you're selling. But you have a way to sell an app, which is different from the browser-based approach. So that's all good. But again, as I've alluded to, there's a couple issues here. One is can't do any of this for iOS until they change their mind and support WebGL in mobile Safari. So in iOS, you have to build an app. But you can build one that has WebGL in it. We're going to talk about a couple ways to do that, and we're going to focus on one way to do that. And for Android, you may want to do it for performance reasons or getting at device capabilities that have not yet reached a browser through an API instead of DOM events. OK, so who's built something with PhoneGap? Anybody? You know about PhoneGap? All right, so PhoneGap is additional code you include in a native application, but in general, you're doing HTML5 programming. So you're building, you got a web view, so you could do HTML5e stuff. You can write your code in JavaScript, but then there's additional JavaScript accessible APIs. So for example, before browsers had device orientation, you use PhoneGap to get that, right? Or geolocation or these other things. Now, as these APIs invade the browser, the need for PhoneGap may go away, right? But more on the bleeding edge of that is the 3D and Canvas stuff. So Lude, company that was showing at the exhibit floor yesterday, I don't know if you saw them, they showed Cocoon.js. They had a table with about 40 devices on it showing these HTML5 apps running beautifully in all these environments. What they've done is they've made several technologies that work together. They have a Canvas API. It's exactly the same as the browsers that's hardware accelerated. So flip of a switch, you're basically all your same drawing Canvas code, Canvas drawing code, except you're going to get a different drawing context to draw to. And Lude just handles the rest for you, and your canvas goes much faster. They have the 3D version of that. They have a WebGL canvas as well. And they not only do that, but they packaged it up so you barely have to know the difference. You just take your code. You have to do a few changes to it at init time. And it's all the same code drawing to 2D or 3D canvases. They also have a cloud-based builder for you. So if you're a web jock, you've got HTML5, and you've never done iOS, they actually give you a way to generate a build in the cloud. You get it back seconds or minutes later. You just need to put those Apple developer credentials on there. You need to learn that part of iOS development, but you didn't have to do any Objective-C or any of that other stuff. It's not open source. I'm not sure they've published their terms of use yet exactly. I think they probably have to at this point because they have thousands of people. It's about 25,000 developers building stuff with it in terms of what the licensing agreement is. Most of their features you can use for free at some level. and then they value add, and you pay for them. So it's sort of a freemium model. I don't think they're ever going to charge you for just building an app, but then they add more services on top, and that's how they make money. There's another way to do this, which is an open source library, so you have full control. It's called Impact Ejecta. The thing is, it's a lot more DIY. You get Objective-C source code to come with it. Also, last I looked, it didn't run on Android, but that may have changed. And it gives you a WebGL API. And you just instance some object in your iOS code, your Objective-C code, and you can do WebGL drawing with it, and it all connects up to your JavaScript APIs at the outer level. So because it's so DIY and involves iOS level programming, and I don't want to get into that here, even though Lude's Cocoon.js is closed source, it seemed like so much of a better way to illustrate the idea. So we're going to look at this. And how we did it was, I thought it would be really nice to be able to build something. Lude was focused on gaming for a lot of the time they were doing this. So let's do something that looks like a game level. So that GLTF file with that spaceship city with the animations, we're going to just look at that again real quick in a completely different context, which is developing this for iOS. So I just took that and slapped the front end on this thing with a little load screen. And we're going to see this, and then we're going to figure out how to port it into the browser with Cocoon.js. And this is just a demo of game-like features, guys. This is not, has a zero, like next to zero gameplay. We're inside a cockpit that's following the camera. I can use the spacebar to launch a missile. Pulse bomb. Yay. I forgot how to actually fire a gun here. Is it the arrow keys? What's my fire mechanism? There's a way to fire the gun. Is that it? No? Did I have a help screen in here? I can't believe I forgot. Hold on. That means it's a really long day. There we go. I'm just hitting up arrow. All right. And that is it. Literally, that's all the gameplay we got. Animated camera, firing some guns, shooting a missile. I just like that sound. We're going to do it again. There's some other behaviors. There's this simple little engine, quote unquote, detecting your proximity to the enemy spaceship. As you'll see once in a while, there's a spaceship that flies across your view. When you get close enough, it'll say proximity alert, right? Right now, we can't find any info, but as the ship gets closer, watch out. And then we're just using, fun div animation to like throw a few things around to give us status messages. So demo of game-like features. Like I said, next to zero gameplay. So how would we do that for iOS with Cocoon.js? Can't just take what I just showed you and just run it with Cocoon.js. Got to make a few changes. So in desktop WebGL, what's great is this is an overlay. It's a div. I see the scene, the 3D animated scene, through it, right? That compositing does not work with Cocoon.js. Cocoon.js can do this great canvas stuff in WebGL. And you give it an app to do that. If you want to put an overlay on top of it, you actually have to create a second WebView control with transparency. And you have to put the divs and everything in a separate HTML file. So you split your stuff out, and then you use Cocoon.js communication libraries. And what's going on under the covers is it's got two WebView controls. It's got its accelerated WebView canvas stuff under here, and then it's got a UI layer. So all that mix and match wonderfulness of desktop WebGL or any real WebGL implementation where you can blend them infinitely, you have to make a compromise here and say, OK, I'm going to use, I like having HTML for my UI. I got all the styling, the buttons there. I don't want to replicate that with a 3D canvas and all this attempt to draw this stuff. It's too much work. So I'm going to use another layer and another web view. So that's part of the technique. And you make your heads-up display, your overlay, using that strategy. So you split your file up into two index files and tell Cocoon about them, and it'll work. So you include these JavaScript libraries they have. Now remember, this stuff's going to end up running in iOS. But it runs on desktop, too, so you can at least test it, right? They've got some ways to basically set that up and make it work. So include the main Cocoon.js. I'm going to include the app file, which says this is my app. And then this one's going to be the way I talk to the HUD. And so then the only trick is for the heads-up display, I adapted my desktop version of this, just created a new HUD right there. And that HUD just talked to the overlay. It's all DOM code. It's all one space we're working in, right? For Cocoon.js, we're going to create a proxy object, which is going to use the Cocoon.js API to send information to the other web view control. So imagine it's almost just like a wire protocol. It's like RPC, remote procedure call or inter-process communication. It's not that. It's all one process, but it's two different controls, and they need to talk to each other. So we split that out. The sound files can run right in here. Cocoon.js has sound APIs. We get started. So our original files just said new HUD. But again, for this Cocoon.js enabled version, I split it out using a proxy object. And then sometimes you want to click on stuff in the UI and have it talk to the 3D scene. So the communication's got to go the other way. So this file is different now. This is the one that's saying this is in my web view, and it's going to talk to the other thing. So now this is my HUD. And now I have proxies for the sound in the game. All right? I'm going to show you these proxy objects in a second. And they talk to the 3D canvas whenever you want to make changes from the 2D interface. And I don't have a slide with that code, so let's just go look at really quick what the proxy looks like. HUD, proxy HUD. OK. So the magic is this. Cocoon.js gives you APIs for the two components to talk to each other. It's called forward async. It's an asynchronous operation which will send a message, in this case, to the web view control that implements the heads-up display, your overlay. And what do you think we're doing in here? Guess what the net result of this is? This is actually passed. I'm constructing a string here and giving it some values, right? This is passed to the other piece of Cocoon.js, which does an eval, right? So if you look at the actual HUD interstate method in the other index file, it's going to be a function HUD interstate with arguments, right? And the magic of a Cocoon.js is it does an eval over in that other execution context, the one where where the heads up is actually running. And similarly, the game HUD, game proxy rather, same thing, right? Now, the only thing the HUD has to tell the proxy is when you hit the start button. So that's the only message it has to forward. A lot of different sound things, I think. Oh, yeah, so see, basically there's only one method, and the sound interstate's just got a switch statement in it to figure out what to do. But that's it. So Cocoon's made it kind of easy to do this inter-process communication between, again, what? It's a web view overlay and a 3D canvas behind it. And this you only need to do if you want to build your user interface in HTML. If you wanted to build a whole game, full screen game for iOS, you could just use the 3D canvas or the accelerated 2D canvas. But you're using HTML5 APIs and JavaScript to do it all instead of Objective-C and God knows what kind of UI toolkit and what kind of game engine. So all of this by way of saying you can take that web app and pretty quickly migrate it right into iOS using Cocoon.js. Again, it's proprietary. That's the downside. They seem to be pretty friendly about their terms of use, which is great. They got this cloud builder and these value-added services. But long story short, it's not so much about Cocoon.js. It's the existence of technologies like this to get the job done. And the benefit, again, what do we care about? We don't want to have to write this code 5 different times for 5 different platforms. We might even be willing to pay the price of it not performing so well on some of these platforms, right? Of course, this very much depends on your business. If you're a game developer, you want to make the first class mobile game with the highest performance, you're probably not even in this room because you've got Unity to help you do that already, or you're writing native iOS and you got your own engine. But if you're like most of us and you want to do some real world work on web time, you're going to explore technologies like this. But again, Cocoon.js is no panacea. At the end of the day, we're still, or the native support we have in the Silk browser or these other environments that implement WebGL already, we still have to think about performance differently than what we do on a desktop. This beast right here masks a lot of performance things you're going to run into when you go to a lower footprint, cheaper device. The first of those is foremost we should be very mindful of when we're building interactive 3D applications or 2D applications that have to run at real frame rates. Everybody know that JavaScript is a garbage collected language? All right? Anybody ever write a JavaScript application that works really well for a while and then stops in the middle and janks and then starts up again? Right? Yeah, I mean, I can write that thing in a second, right? It's much easier to do that than to do the one that doesn't do that, right? And so we need to be really mindful about what we're doing here. So especially when we're doing game and interactive media, 3D things, one of the first things you want to do is, if you can, try to pre-allocate your memory as much as you can up front. That avoids the jank we're talking about, which is, hey, it's going great for a while. It loaded fast. It's going really great for a while. Then it stops right in the middle of a frame. A game application, that's death. For other apps, you may be able to survive it for a while as it garbage collects. But really helpful if you can pre-allocate your memory. It's a lot of work, because basically what you're doing is you're doing new and trying to do all the new of all the things you might expect you might use. And then later on, go use them by passing an ID or something and go get me one of these. Or a type of object I need, go get me one of these new kinds of objects. It's a little more complicated than what we're used to in JavaScript. Kind of defeats the purpose of a lot of what we do in JavaScript, which is dynamic and easy coding, but may be required for the environments we work in. And along with that, maybe you're pooling. So in other words, you've got this pre-allocated array of stuff, but maybe you can reuse bits of it. Box2D's JavaScript implementation, that 2D physics engine, pre-allocates everything and uses reusable pools. So you don't ever say new in that context. You say Box2D, give me something of this type. And it will pool, it'll reuse stuff that you've got, and you'll say Box2D, I'm done with this. I don't know about you, but this is very easy to do in JavaScript, right? Return, handlebar, stuff, colon, more stuff, colon, more stuff, close handlebar. Every time you do that, that's a new. You didn't say new, but that's a new, right? Everybody know what I'm saying? Yeah. Got to be very careful. Imagine doing that 60 times a second to respond to events when you're rendering your frame rate, right? Because you're going at fast frame rate, but you're generating garbage at 60 hertz. This can be death for memory. Watch out for your closures. It's very easy to create closures, especially if you've got callback functions left and right. So just a general performance tip, important here. And again, avoid explicit news per frame by pre-allocating. We are working with smaller, cheaper devices. This thing's only $229. This thing's $1,300, right? How did we get there? Components are cheaper. Less powerful in general. So that means, watch your algorithms. That means maybe deliver lower res stuff. The GPUs are less powerful. Sometimes that means they won't actually handle shaders that are complicated. They'll be able to execute fewer instructions and everything. So don't have time to get into those details here, but you may consider deploying, based on user agent detect or capability detection, simpler shaders, but still programmable shaders, maybe just with not fancy lighting or other things that really tax a GPU. Let's not forget, we're on 4G. It's getting better all the time. There are issues with it, though. You may go offline. Your network may drop out. You need to think about that. Maybe you batch your assets into your app. It's antithetical to web development, but if you're building a game and you know about it, you know everything that might get loaded. Now we're in the future during the life cycle of this application. Package it with the app, maybe. Obviously, in iOS world, Apple gets really bent out of shape if you actually download assets later, and they can reject apps from the App Store based on that. They don't like downloadable content. So in some cases, you have to do it. Use that browser cache if you can, if it's a browser-based app. That keeps the network traffic light. Batch your assets. This is just a performance technique. So just like CSS image spriting or whatever. If you've got lots of texture maps you're using, consider batching them together because you can model your data so that textures are shared. And you can have 5 different objects use the same texture map, just indexing into it differently. And so you basically packaged it up into a batch. Why would you do that? Why would you do that for web performance? Why would you download a bigger texture instead of 5 smaller ones? To avoid the number of requests over HTTP, to lower them, right? To reduce them. Standard web performance technique. And then as I've sort of alluded to with these binary and compressed formats like GLTF, try not to deliver big, fat, clear text files. I mean, that's probably just self-evident at this point. At least 50% of the motivation for the GLTF format is to work on mobile as well, not just be faster for the desktop, because it's critical in a mobile environment. So let's summarize. We're on the home stretch. Again, we didn't even talk about CSS3 today, but if you want to explore it, you got nothing to worry about. It works everywhere. WebGL works most everywhere and allows us to build prepackaged stuff or browser-based. iOS, we have to go hybrid for now. We have to think very carefully about performance. But the net of this is, you know, in the large, I mean, there are still issues and challenges. Cross-platform 3D with HTML5 is now possible. So I was very excited. I'm personally pumped about it. I don't, for my own use, don't have a lot of use for a serious 3D app on the phone. But on an iPad, tablet, you know, I'd like to be able to do this Cocoon.js style stuff. And I'm going to show you Cocoon.js Omega City right now. There it is again, cue dramatic music, and there I am. That was using Cocoon.js. And I am frame rate challenged. My frame rate counter is telling me 16. That's not great, but I haven't optimized this. I haven't done a lot of work with it. I just took it out of the box and did the HUD adaptation I showed you. See if the double tap worked for me. There we go. It's my missile launch. Look carefully. Pulse bomb. Tap and hold. My rifle firing. So, you know, that was a day's work. What could you do with a little more effort, right? All right, guys, that's it. It is 4:21. Oh, that's a good time of day. You know, I can hang for another half an hour. I'm not expecting anybody else to. I know it's been a long day. We didn't look at that CSS stuff. That was the only section we really skipped of import. You can look at that on your own. We could just kind of demo a few things and look at what's possible and not take 5 minutes and not get into all the details of it. You guys up for that? You can be packing up and I'll just flash up a few CSS demos. How about that? And I really thank you for your participation. This is the best group I've had so far. Now the sample size is only 2. I did this at the October conference, but you guys are in the lead right now. Really great questions, really sharp, especially considering most of you hadn't touched WebGL before, hadn't done 3D development before. So, you know, I think you're all in a pretty good position based on your skill sets and knowledge. You're going to be able to get up the ramp pretty quickly on this. You got it, and that was great. So I'm gratified by that, and I'm encouraged.
For someone that's totally new to 3D modeling, but wants to like play around with the modeling tool, do you recommend one of the like Blender, 3ds Max, or Maya?
I'd recommend Blender because it's free, but the user interface is it's just so crappy. I mean, all 3D modeling tools are pretty awful in terms of the UI. You know, have you ever used Illustrator? It's like Illustrator on steroids in the worst way. It is so hard to use. And project setup, and there's like, you open up Maya, and there's like 40,000 menu items. And Blender's all that, plus the most counterintuitive way of using all of that I've ever seen. So I wouldn't say Blender. SketchUp? SketchUp's not bad. You draw 2D shapes and extrude them. It's really easy to get started. There's great tutorials on it. Export some version of Collada that you can get into this pipeline. So that's what I was going to say. I would recommend SketchUp as my top learning tool. Maya, now there's a learning edition of Maya where maybe they've cut the number of menu choices in half, so that could be a good way to learn. They're trying to get people, you know, on that path, cradle to grave. So let's see, what's interesting here? I'm actually going to show you, rather than these little techie demos, there's a finished product that looks really cool. So check this out. This is CSS 3D transforms. There's no WebGL in it. You can see the spine of the books. That's really cool. Flip it around to the back. You can look inside it and turn the pages. Well, flip the pages. So that was all done with no WebGL. And every element we're looking at is a div. Now, when you're looking at the spine here, You know, those are some weirdly transformed divs. This is not one object. There's several flat surfaces that combine together to create this effect. But what this says to me, what this suggests is you can do things like a Netflix-style channel tuner or some other fancy interface that's got these kind of effects, flips, fades, transitions, and tweens, without having to learn a library like Three.js, without having to muck about with lots of JavaScript, and still get some pretty amazing effects, which is why I cover it in the book. Because the book's about 3D programming, not about which rendering technology you use to do it, right? So to me, this is hella cool. And that thing we started with today with 100,000 stars, that combines these. So the labels for all those stars were scaled based on rollover and based on proximity to where you were using CSS 3D transforms, not using WebGL, even though the main presentation was done in WebGL. So that's a combination of the two techniques, which to me is really exciting. You know what's a little bit trippy? Is that div could have a WebGL canvas in it. And you could have a spinning 3D animation inside your page, inside a book, inside a 3D transform. That's pretty cool. I might even have a demo of it somewhere. I'm too tired to look it up. And then, OK, we want super mind-blowing. I got to show you one more thing, and I got to find the URL for it, because it's sick. OK, let's see here. I don't know what it is about guys from the UK, but they seem to be rendering jocks. And what he's done that's unbelievable is he's created a first-person shooter using nothing but these CSS 3D transforms. That cylinder, OK, where's the live demo? Come on, show me where the damn live demo is. Ah.
The link underneath in the slide just goes to that.
Look. Mouse look. Look at this. Look at WASD to move. Yep. Can you believe this? Can you believe it? Oh, the experiment's been updated. Let's check out the new demo. With cutouts, with PNGs. There's a lot of fakery. Look at this one. And the light mapping is all like crazy stuff, generating gradients. I think it even has like 2D collision. Yeah, I'm colliding with the can here. This can is like faked 3D geometry as well. I'm stuck here. Come on. There we go. WASD. I mean, that is like, dude. I was just about to say too much time on our hands. Oh, look at this. Is the spacebar shoot? No, that jumps. Yeah, I don't remember. I don't think there's a way to shoot. I think it's just moving around. It's an FPS with no S. It's an FP. Something. First person FPA. There you go. Now, he might have something. I just don't know how to do it. I mean, you know, but well, yeah. Now that's some crafty, creative stuff. I wouldn't suggest that for the faint of heart. If you got WebGL, you'd never use it. If you got a canvas renderer, you'd probably never use it. But that's how far you can go with this, and you know that's amazing. Famous had that, as I mentioned, has a periodic table demo. Well, Ricardo's CSS3 renderer for Three.js can do the same thing. Those div elements are just thrown around in space. Virtual product box. This is the, like the book. It's just a box top. It's playing all those same tricks. So some people have sort of pushed the envelope. And if you want stuff that'll run on your phone and just fit in small form factor, you don't want the overhead of Three.js and those 400K minified. And you don't want to get into the build system and rip stuff out. Maybe this is the way to go. All right, ladies, gentlemen, thank you. I've lost my voice. You've got all the info in the packet. Get my book if you want to learn more. You know how to find me as well. I would love to hear from all of you as you, journey through your WebGL and your CSS3 and your canvas rendering. Again, thanks for the participation. It made it really enjoyable for me. If I don't know if there were course evals. Did they pass them out even? No? No. If you get an opportunity to evaluate me, I hope you say good things. I would say good